My name is Austin, and today you're going to learn about some correlations between kinematics and basketball. Kinematics is the study of motion of objects without considering outside forces that are acting upon it. It begins by describing the geometry of the system, the initial velocity, final velocity, acceleration, change in position, and time. You can use the uniformly accelerated motion, or UAM equation, when the acceleration is constant and is a real number, to find out other variables in the equation. There are 5 UAM variables, 4 equations, so if you know 3 variables, you can find the other 2 variables. Some basics in kinematics include vectors and scalars. Vectors include magnitude and direction, while scalars include magnitude with no direction. For example, momentum is a vector. When there is a collision in 2 dimensions, you have to break it up into components. You break it up into x and y direction because it has direction and it isn't a scalar. Another basic is distance and displacement. Distance is the path traveled and is a scalar. Displacement is a straight line distance and is the change in position of an object, meaning the position final minus the position initial. And displacement is also a vector. Speed and velocity is also different. Speed is the distance over time, while velocity is the change in position over time. Speed is a scalar, while velocity is a vector. Projectile motion is when an object is thrown near the Earth's surface and travels along the parabolic path under the force of gravity only. We start solving by splitting your known variables into the x and y directions. In the x direction, the acceleration is 0, so it has constant velocity. You can get velocity by the change in position over the change in time. In the y direction, it is under free fall, meaning the acceleration is negative 9.81 meters per second squared, which is the acceleration due to gravity. You can use the UAM equations in the y direction. Time is a scalar, and it is the same in both directions and is what connects the x and y directions. The range equation is the range of an object in projectile motion. It is the displacement of an object in the x direction, while the y direction is 0. It does not mean that the object does not move up or down, but instead it means that the change in the y direction adds up to 0. The range equation is given by initial velocity squared times sine 2 theta initial all over the acceleration due to gravity. The maximum value for sine is 1. So when you put it into the equation, the maximum angle is 45 degrees. In that clip that you just saw, it was me shooting a free throw about 15 feet away from the hoop, demonstrating projectile motion. For every shot I had, it was almost the same initial velocity, and I shot it at a 45-degree angle for maximum range. One classical equation of projectile motion is basketball shooting. The ball follows a curved path, which models a parabola. Shooting a jump shot heavily relies on proper mechanics in order to launch the ball at an angle and velocity that will ensure that the ball released will have the best chance of going in. A basketball player must be able to use their mechanics to jump straight up, extend their arm, and follow through using their wrist in one fluid motion. The ball should be fired at an angle that would travel at a vertical distance above or over the rim, reaching its maximum height, and accelerate downwards into the net, all while maintaining a constant horizontal velocity. This allows projectiles such as a jump shot to be launched vertically at an angle to a target, the hoop, above the release point while moving horizontally. Skilled shooters know how to alter the velocity and angle or release to make their shots from anywhere on the court. For example, shooters snap their wrist to follow through faster when shooting a shot further away from the hoop in order to acquire the necessary velocity and angle to score. fundamental skill in basketball is passing. In that video, it shows me passing the basketball to my friend who's about the same height as me, and we're passing it and catching it at almost the same height, which means that the change in the y direction adds up to 0. So that means with every pass, only the x direction is changing, but not the y direction, meaning that it obeys the range equation. But in basketball, not every pass obeys the range equation. Sometimes they can throw it and catch it at different heights, so that means the range equation does not apply in those situations. Now you know some correlations between basketball and kinematics. Thank you.